Access control models are methods to control user access to files, folders, and systems. Access control methods provide authentication and authorization. They authenticate users with a set of credentials, and then they'll authorize users to a set of resources. Different access control models have different uses and different applications. They have different methods of enforcing and controlling authorization policies. User privileges are usually assigned to a network or to a group of cloud users using tools like Windows Group Policy Editor or through Lightweight Directory Access Protocol. When it comes to cloud computing, access control is usually assigned through a directory instead of a traditional group policy. Role-based access control will attribute access based on, as the name suggests, different roles. So users are placed into a role, and then their access to the resource is dependent on that role. So you might have different privileges associated with different roles. So for a firm that has a sales department, the sales team might have access to sales folders, sales software, and client list, while a manager and HR representative would have employee records and payroll software. So different roles would be decided upon by the organization, then assigned to users, and privileges would be associated with those roles. Role-based access control can be hierarchy-based. So you might have a user like a manager who would have more privileges than individuals within the department that that manager manages. So for example, a manager of a sales team, Michael, might have more privileges than the salespeople, maybe Jim and Dwight and Phyllis. So Michael would be able to access the same resources that Jim, Dwight, and Phyllis would be able to access, but Michael would also have access to many maybe management tools or maybe payroll that HR also has access to give him more privileges, more capabilities. If additional individuals are added to a organization uses role-based access control, a new role can be attributed to them, maybe for like a temp worker. So this can be used with cloud computing as well to provide access based on a user's service level. So maybe users have a free account, or a cloud service provider provides a free account and then has various tiers that can be upgraded. So users would purchase upgrades or purchase access to different tiers of service, and that would be controlled based on that role-based access control. So you might have like a free membership, or then maybe a silver membership or a gold membership, and each of those memberships would be a different role. Roles can be set to individuals individually, or they can be accessed through groups and managed through groups. And manage it through groups makes it very easy for an organization to perform access control, because the group and privileges can be assigned to that group. So you can have a sales group in our sales example, where individuals in the sales team would have access to sales information. And then you can have a manager group. So if an individual is promoted from the sales team to a manager, maybe Andy, then you can have that person taken out of the sales group and put into the manager group. It's a lot less labor intensive to manage roles using groups than it is to manage it using individually. This also helps enforce least privilege. Rule-based access control uses specific rules to control user access, and rules are governed by access control lists, or ACLs. So rules will be listed within those ACLs and recorded within ACLs, and then applied on an as-needed basis. Firewalls use ACLs, and firewalls are a great example of rule-based access control in use. So with those ACLs, you can have rules that can then lead to additional actions. So a firewall might refer to an ACL to deny all traffic from a certain IP address. And then a corresponding action to that could be deny all traffic and then inform or send an alert to X administrator, or detect traffic on this port, and if traffic exceeds this amount, or traffic is stemming from these source IP addresses or these source ports, then disable all access to that port. So that's how intrusion prevention systems work, and many times they'll refer to a set of rules, an ACL, to determine what actions to take. Discretionary access control, or DAC, designates objects. Objects are things like files and folders, and then each object has a designated owner. So the owner designates the permissions for those files and folders, and this makes the user in charge of access control. So you can, as the controller or as the owner, you can assign who can access that file and folder. You can restrict or make the folder available to everybody if you choose. The Windows operating system is a prime example of discretionary access control, and most Windows deployments use DAC alongside NTFS, New Technology File System. Within NTFS, Windows uses special ACLs called DACLs that are used to record those user permissions. So each object is then granted a security identifier. So each object, if you're using Windows, your files and your folders, they all have security identifiers, usually hidden to users, unless you really need to search for them or reference them. But they're used by Windows to determine who, in the background, who has access to what, and who the owner is, and what permissions the owner has set up for those files and folders. Some examples of permissions could be read-only, write or modify, and then the owner, which would have full permissions. Mandatory access control is a type of access control usually used within federal governments. This is where sensitivity labels are applied to data, and it's often used with classified information. For the U.S. government, this takes the form of 3 levels of classification: confidential, secret, and top secret. So data will be applied each one of 3 levels of classification, and then access to that data can be controlled based on that level of classification. In practicality, mandatory access control is not, you won't find a system where you would only get access to a certain type of data depending on your clearance, and that system would have access to all types of classified information. In actuality, those systems are clearly marked and clearly segregated from one another. So you would have a system that would only process confidential information. Then you'd have a system that would process secret and confidential information. It's a hierarchy base, confidential being the lowest level classification, top secret being the highest. Then you'd have a system that would top secret system that could process top secret information, secret, and confidential. So, but in theory, it works very well. In order to access different levels of clearance information, you need not only the clearance commensurate with that level, but you also need what's known as a need to know, or the information needs to pertain to your job and your skill set. Otherwise, there's no need to know, and you should not, under mandatory access control, be allowed to view that information, even if you have a clearance to view it. Attribute-based access control is a form of access control that assigns attributes to users. And these can be anything the organization deems necessary. I find this very useful within the financial sector, particularly for financial advisors. Financial advisors need to be licensed in the state for of the clients that they're advising. So if they're not licensed to advise clients from Rhode Island, then they can't take clients from Rhode Island. So financial institutions that offer financial advice can create an attribute that is, an attribute linking their licenses of their personnel to various states, and then filter callers or clients to those users based on those attributes. The attribute can be licensed in Arizona or licensed in Rhode Island, and then the user can or the customer can get to somebody who is actually licensed and can actually help them. Attribute-based policy control or attribute-based access control uses almost plain text statements. So it's a policy statement. You'll find that statement includes 4 parts: the subject, which is the user, the object, which is the resource that the user wants to access, the action, which is what the user wants to accomplish, and the environment, which are any attributes outside of subjects and objects. For example, you can say something like, all Red Hat employees are authorized to access databases at the Chicago office on Wednesdays. With that statement, we have the subject, which is Red Hat employees. The object are databases. That's what the subject wants to access. The action is access. They want to access. That's the verb that they're doing. And then the environment is the Chicago office and Wednesdays. Those are the conditions. So you can clearly, with that statement, list it out using ABAC, or attribute-based access control.